Hi, I'm Suwansang. I'm a BenQ brand ambassador, and in this video what I would like to show you is how to calibrate the BenQ SW series of display. Now, BenQ SW series of displays are designed specifically for photographers. It can display 99% Adobe RGB. It has a delta E value, that's a color variation of less than 2, which is really awesome right out of the factory floor. Each one of the monitors, or the display for this matter, before they leave the factory floor are all calibrated using a really high-end calibration device, and it also comes with their own report card. But more so, what I want to do is that even though they are pre-calibrated from the factory, if you want to get the best color possible, you need to calibrate your display, because calibration for display is actually per computer, per display, per video card. So if you have multiple video card, multiple outputs and so forth, you want to recalibrate it, because every output on the card kind of outputs a little bit different signals, so you want to make sure that they are calibrated specifically for the display. So I'm going to go to the display here and we'll kind of get rolling on that. One thing though to kind of keep in mind about the display calibration itself is that when you're using a hardware calibrated display, yes, the computer does generate a profile, but that profile is just telling the computer to output everything at 100%. That means red, green, and blue color, just max it all out. All the adjustment is done within the computer inside this panel. And the computer inside has a lookup table called a 3D LUT. It stands for 3D lookup table. It's a 14-bit. It's pretty much like a color matrix, like literally a whole bunch of colors that the screen goes through in order to calibrate the display with the color calibrator. Now, the display that I have here is a BenQ SW2700. This is a 27-inch 4K display from BenQ. It's the third in the series for the SW series itself. And what I'm going to use to calibrate the display today is the x-rite i1 Display Pro. Now, a couple other things to keep in mind as well. I'm also a colorati with x-rite, so one of their color expert. But another thing to keep in mind as well is that when you have BenQ SW series line display, BenQ have come up with their own proprietary software to do hardware calibration, and that software piece is called Palette Master Element. One good tip for you, for all of you viewers out there, is that if you just purchase a display, I would just forget the CD that comes with the display, and I would go directly to BenQ website and download the latest Palette Master Element software. This way you're running on the latest version with all the latest updates. So that's number one. Secondly, the Palette Master Element software will work with other calibrators as well. It will also work with Spider, and they're also building more support for devices up in the future as well. Now, what I like to do is I'm going to go ahead and launch Palette Master Element. And the process to do this on a Macintosh and on a PC is fairly similar, and it does pretty much the same thing. But in this case, we'll be using a Macintosh to kind of do this. We're going to launch the software. It does take a little bit to launch, and then we'll kind of go from there. Now, what we're going to see here in a moment is that we'll see an error dialog popping up. And this is something that's fairly common with the display, and it's not because it's a display fault or anything. It says a connection to BenQ display cannot be established. Please make sure that the USB cable is connected and the FTDI drivers are working. I mean, what is an FTDI driver? I don't know what that is. As much as I'm a geek, I really don't know what that is. I did some research on that once. What it really comes down to is that Palette Master Element needs to have the USB 3.0 cable being plugged in. So I'm going to go ahead and plug in the cable right now. And then we're going to try to launch the Palette Master Element again. Now, I just leave the display on here in this case. We'll see what kind of happens, and if it gives us an error again. Wait for it. Everything goes through this time. Now, if you should plug in a USB 3.0 cable to do the data link between your computer and the display, and it's still giving you an error, one of the ways to kind of get rid of that error is to do a hardware reset on the display. And the way how you do that, super simple. Just pull out the plug on the back of the display, leave it out for about 30 seconds, plug it back in again. This way you're refreshing the hardware of the display. So if the error still comes up, make sure you have the USB cable link and is working, and then also pull the plug and plug it back in again. But otherwise, it should just show up. I'm running on the latest version of Palette Master Element right now, so we're going to see a couple of settings are being given to us here. Number one, our monitor SW271. If you have multiple BenQ displays, you can actually tap on the drop down list here. In this case I don't, but it will list all the displays so you can calibrate, so you can specify which one you want to calibrate. So number 2, I'm going to go ahead and click here, and this is a calibration device. So if you can kind of see here, there are multiple calibration devices that you can use. I have the i1 Display Pro. I'm going to use that. It's going to automatically detect for me. But if you have another device, i1 Display 2, i1 Pro, i1 Pro 2, Spider 4, Spider 5, those are all valid calibration devices that you can use to calibrate this this hardware calibrated display with the Palette Master Element software. So in this case, I'll select i1 Display Pro. You can click on Check Sensor. The only when you want to click on Check Sensor is that, for instance, this one right here, this button there, if it shows a red, kind of like an X circle with a a red circle with an X in it, that means it's not fully recognized yet. So you want to click on Check Sensor. This way it can show you the check mark, and it will redetect a sensor. Now, there's 2 modes of calibration. There is basic and advanced. I kind of like advanced, and I recommend that all photographers use advanced in this case, because advanced gives us a lot more control, a lot more granular control over the calibration process. So we'll click on Start here. There's 2 things that we can do. It kind of lists the display spec right here: mode, advanced, calibration device, i1 Display Pro, and the monitor. So you can kind of see what you're calibrating, which monitor, and so forth. Kind of neat. So there's 2 workflow you can choose from. There is profiling and validation. So normally what I would tell everybody to do is to start with profiling first, and then what we're going to do is that we're going to come and click on Next. Now the next page, this is where we go over all the settings for calibration. So we need to kind of pick our settings now. So number 1, we're going to choose, there's kind of like a few settings that you can do. One of them is the default for photographers. There's like web design, sRGB, graphic, Adobe RGB, cinema, DCI-P3, which is something that's used in cinema a lot. Or if you're doing video editing, there's like Rec 709. So all these different color spaces you can use. And there's different ones, and you can create a custom one as well. And so in this case, I created one called Art. Obviously, very non-descriptive, very bad description, so don't do that. So I'm going to click Photographer, Adobe RGB. We're going to use, in this case, what I recommend is to use a D65 setting. It's probably one of the best white point settings for a display. RGB primary. In this case, we're going to select a Adobe RGB. So we're focusing the display during the calibration so that it focused more on the Adobe RGB value in this case. All right. So the luminance, in this case, we're not going to go maximum. The maximum of this panel is close to 400 candela. That's about like three and a half times as bright as an actual print that you would print on your wall to display, or like that print back there. So we need to control that amount. The default value that BenQ have set for us for photographer is 160. From my experience, and I've been doing this for more than 10 years now, 160 is too high of a value. The value that I recommend that everybody sets to is somewhere between 80 to 120. My personal value that I like is 80. What I'm doing with the 80 candela value is that I'm setting the display to look a little bit darker. So if I actually edit a little bit brighter, it will look okay in normal household settings, because in household settings we don't have lighting like we would normally have in a gallery and so forth. So having it a little bit brighter is okay. You don't want your display to be too bright though over on the setting. For example, like I said, 160 candela, the default value is too bright, because everything will look great on the screen, and then it looks awesome on the screen. You send it to print, you send it to your Pro Lab, you print it through your Epson printer or any other inkjet printer you have in-house, whatever that may be, and you're going to find out that the print looks darker. That's because 160 value is a little bit too bright than actually a printed value. In order to have something that match, like I said, a value between 80 to 120 works great, and 20 increments works amazingly enough. So 80, 100, or 120. Now if you set it to 90 or 110, will you see a difference? It's going to be so minute. That 10 candela, you won't see that much of a difference at all. So in this case, I'm going to go ahead and set it to 80 candela to custom. Gamma, we're going to leave it a default 2.2. So we'll kind of leave it at that. And then for the black point, you can two different things to it. It's kind of very interesting. This is kind of the deepest, darkest black. And this is something you kind of have to experiment with. And I would do the experiment by picking which black point and seeing which color you like better, and also do the display profile validation at the end, which I'll also show you how to do that as well. Absolute zero will try to bring the black point as down as close to zero. That means like true black. I mean, obviously these are LCDs or not OLED or anything like that, so they can only go so dark on the dark pixels itself. The other thing that you can do is also set the black point to relative. When you set the black point to relative, it's going to set the black point relative to the darkest black that the display can or is able to get to. So this way, I'm going to do this one, so we'll see how our profile looks in the end. You can set the different modes here. We're not going to worry about that. I'm going to go ahead and click on next. Now this screen is fairly important because this screen you're setting a couple things. I mean, obviously all the screens are important in this case. This is also important as well because number one, we get to choose our calibration preset. What is a calibration preset? Well, if you watch my review videos of these BenQ displays, in the older generation it has two calibration preset, calibration slot 1, calibration slot 2. In the later generation, for example, the SW2700, which is this one, the 4K display, or the SW240, which is your 24-inch kind of entry-level one, has 3 slots for calibration. 3 slots is really awesome. That means you can have either 3 devices hook up to it and have a custom calibration for all of them, or you can do some other creative calibration as well. For example, you can do dual luminance. That's something that I'll show you in a separate video as well. Essentially, you set up calibration 1, so is that, for example, is at 80 candela. You set up calibration 2, so is at 120 candela, so you can kind of jump back between the two. And the nice thing about having a third slot is that, for instance, if I have a laptop, I do have a laptop, and what I can do is I can plug the laptop in and calibrate it with my laptop and set the calibration slot to the calibration 3. This way I have much flexibility in terms of how I want to use this calibration slot. In this case, what I'm going to do is I'm going to calibrate it to the calibration slot 1 because this is my primary computer I'm using and this is the primary display. So I'm going to go ahead and do that. It's going to come up with the ICC profile name, and the ICC profile name in this case is going to give you super specific information. For example, the display itself, which one is it? Is it number 1, number 2, number 3? What's the white point you guys have set? D65 in this case. What's the RGB primary? What's the luminance level? What's the gamma? And then what's, all the reference and so forth. So it's going to give you a lot of information, more than you need. Really helpful though if you're trying to look at the profile later on and you're wondering like, what setting did I use for this? Very helpful for that. I'll leave that there like so. Profile version in this case, we're going to go ahead and use version 4. There's no need to go backwards into version 2, especially with display calibration. Version 4 works perfectly. Profile type, you can select different ones. Matrix in this case is going to work the best because it's going to look up, 3-dimensionally throughout the lookup table to match the color as best as possible. You can also do either 16-bit or 8-bit as well. Personally, every time I calibrate it, I do a matrix just because it's looking at the largest, it's referencing the color, the lookup table, in the largest way possible. And then patch size. Essentially what it comes down to a patch size, that the larger the patch group set, the more accurate it kind of is. So what I'm going to do here, in this case you see is small, there's only so many colors itself, most of it focus on black and white. What I'm going to go do is show you the medium. It adds a few more colors. But what I want to do is I want the colors to be super accurate in this case. So I'm going to do a large patch size. It will keep the same number of black and white, and what it will do, it will add a whole bunch of color patches to this so that it actually measures all those color patches. From now on, what I'll do is I'll click on Start Measurement. It's going to show at the bottom here. What we need to do, and this is going to be specifically to each different device, and this device itself is the i1 Display Pro. What I need to do is pick the device up, pull this out like so. It's like a cap that comes up, so pull it up, rotate it, so this way, it can hang from the screen itself. So then I'm going to go ahead and click Continue now. And we'll give it a second. Now you want to adjust this counterweight so that it, it counterweights it enough so that the hockey puck, or in this case the color calibrate, doesn't drop down. The other thing what I will do as well is, not only that, I will line it up, but I would also tilt the display backwards as well. This is something crucial, and if you're not doing this, you may not get the most accurate color calibration possible, because if you ever look at it from the side angle like I'm looking at now, you will see that the moment that I tilt this that I tilt the display and I set this so that, you know, I adjust this chord a little bit more. Colorimeter in this case, the i1 Display Pro, is laying flat against the screen. If I have a straight, sometimes it angles out a little bit, and that causes a lot of stray light to come in, and that changes the way how the color measurement is being done. So I'm going to go ahead and click continue here, and this is going to go into and we're going to fast forward this portion of the video because it does a lot of things. But before we do the fast forwarding part, what I like to share with you first is right now what the calibrator is doing is that it's talking to the display and is measuring the current luminance, and is going to talk to the 3D LUT, the 3D lookup table, and it will show you in a second here that it's like, you know, writing LUT and so forth. Then it will do the color calibration. So I'll jump on every so often to kind of interject and show you what's going on. Otherwise, we're going to fast forward this. But again, like you see here, it says writing LUT. So what it's doing right now is writing to the 3D lookup table. Now, while I'm on right now, I like to take this opportunity to explain to you as well that because you purchase a hardware calibrated display, whether you purchase BenQ or any other brand, in this case we're specifically talking about BenQ, you want to use a software, the proprietary software that's designed by the manufacturer for that specific display or display series. The reason why is because there are some misconceptions around the internet saying that, oh, I brought a hardware calibrated display, like x-rite i1 Display Pro, and I'll use x-rite software. What you're really doing in that case is you're not really doing a hardware calibration, you just have a hardware calibrated display and you're doing a software calibration on it. With x-rite, what it does is it creates a profile, and that profile is more so similar to like shooting RAW and JPEG. And I'll explain that a little bit more as well. When you're doing a hardware calibration, it's, you know, the profile is there, but the profile is telling the computer to output RGB at full spectrum. So all the adjustment is happening right now via the software and the colorimeter. So in this case, the computer is outputting full RGB, doesn't matter what it is, there's no signal compression at all. And it's adjusting inside the display. If you didn't use this process, the calibration is going to be quicker, number one, but you're also doing a software calibration. Software calibration, what it's doing is that it's manipulating the output signal from the computer, so it could compress the red, compress the blue, some of the greens and so forth in order for the color to match, but it's not sending out full signal. So you're really doing a software calibration, you know, kind of like a software profile. So if you purchase a hardware calibrated display, use the proprietary software. They design it so that it talks directly with the hardware the computer is built into the display, and that's how you're going to get the most benefit out of it. And now what it's doing is that it wrote to the lookup table, and now it's doing some measurement for brightness. So you'll see the display adjusting the brightness and so forth. What it's trying to do right now is match it as close as possible to 80 candela. And now what we see here is that it's measuring all the color patches. You can see color patches coming in right here. In fact, what I'm going to do in this case is I'm going to move this to the side. And it's kind of cool because you see each different colors being filled in and so forth. So literally the top one that you see, the top half that has like all those half, those are the reference color. Those are the predefined values that it's supposed to have or how it's supposed to look. The bottom one is the actual measurement and what it looks like. Now, if you have done this using another software, for example, using the x-rite i1 profiler, you'll see that especially on a Mac laptop or any other laptop for that matter, that the color is really off. So that's also another benefit of owning a hardware calibrated display, is that, you know, you're going to see the colors in this case look much closer to what the reference color is supposed to be. But that's also very something to consider as well in terms of getting a dedicated hardware calibrated display that are designed to display all the colors in the most faithful form possible versus a multi-purpose display per se. So there is a difference in the panel quality, the software, and also the hardware that's built into the display too. In this case, I'll stay on camera because we're almost done with the hardware calibration. You can kind of see there. I mean, if you really look at it, the colors are just slightly off or not that much off at all. So that's kind of really neat, but that doesn't mean anything per se, because the nice thing about having the i1 Display Pro or any other colorimeter or color spectrophotometer in that case is that they're measuring it at the granular level, so they can see minute differences that we cannot discern with our eyes, which is really awesome. So it's going to go through here. It's done with the measuring. It says writing LUT again. So based on all the values that it's gathering, it's comparing the data between the 3D lookup table using a software, and now is writing all this data to the hardware inside the panel. And this is why, like I said, you want to use the proprietary software that comes with the display, because it has all those information handy for you, and it actually talks directly with the hardware that's built into the display. Because here's the case. What it comes down to at the end of the day is that if you're going to spend, you know, a good amount of money to get a really nice display, you want to use the right software with it as well. So it's going to write the LUT for a little bit here. We'll fast forward this portion of the video and we'll come back and show you what's the final result look like, and also how to then go do the validation process as well. It's almost done writing the LUT. So the part that takes the longest is, as you can see in this video here, it's not so, and I fast forward this, it's not so much the part that it does the color measurement, it's the writing of the lookup table that takes the longest in the beginning and the end. And what it's doing right now is it's doing some final color verification. So don't be surprised if your display look absolutely wash out at the end process. Because, you know, once it writes and it finalizes the result to the lookup table, it's going to look a lot better. I hope. I'm just kidding. It will look a lot better, so you'll see that in a moment here. Now we have display looking fairly normal, and it is done. So once the calibration is done, it will give you a few results. One being is that it's going to tell you like what display, manufacturer display. Obviously it's going to be BenQ. It's not going to really work with other manufacturer display in this case. What serial number it is display, I guess that's always good information to have. The profile name, like I said, the long profile name, and at the end it has like the date and a timestamp to the profile, which is kind of neat. The target luminance value. The target luminance value is the value that we want it to be, and then the achieved luminance value, that is the value that it was able to get. In this case, we set it to 80. We wanted to target at 80. The calibrator working with Palette Master Element software was able to get it to 80.87. So minute. I promise you, the 0.87, you won't see a difference at all. Our eyes cannot discern that. Target temperature, in this case we set it for D65 or 6,505 Kelvin in this case. The achieved temperature is actually right on 6,505 Kelvin. This is really awesome. One more tip as well that I want to give you about hardware calibration on any display like this is that you want to leave the display running for at least 15 to 20 minutes. So if you just pull this out of the box right away, you plug it in and you just start calibrating, you're not going to get the most accurate color possible. So make sure that you have it running, give it some time for warming up before you do the calibration. Now before I finish here, what I want to do here is come into validate calibration. Okay, so validate calibration will do a couple things. So it'll tell me to flip the colorimeter again. In this case I have. It will ask you a few questions in this case. So we'll ask you what calibration you want to validate on. In this case we just calibrate the calibration slot 1, so we're going to do that. What profile version, what profile type matrix, and so forth. Patch set, we're going to do large. Average delta E will set to 2, maximum delta E to 4. In fact, let's change that so that maximum delta E is 2, and we'll set both of them to 2. Technically, the average delta E should be below 1 in this case, so we'll see if our calibration was good. I'll go ahead and click continue. Now this process is going to be a lot faster than when you're trying to initially calibrate the display. So I'll line it up, line up the colorimeter with the outline of the colorimeter on the display, just like so. We're going to scroll down to the dialog here. Once it's lined up, click on continue, and it is going to start measuring. You'll see that in a moment. So it start measuring the color right away. In this case, it's validating how accurate those colors are, and it's not so much doing anything else. So it's not really changing or adjusting the lookup table or anything like that. It's just verifying the colors. In this case, for some reason, my calibration was not really good, so I'm probably going to go back and rechange the setting again, but the average delta E in this case is 1.09, which is okay. Our maximum delta E in this case is 2.5, which is actually technically not bad. And the maximum delta E is, let's see, which color is it? Oh, I need to move the screen over a little bit more right there. Our maximum delta E in this case is in the black value, amazingly enough. Actually, no, yeah, it's actually in the light gray value. So remember earlier in the video where I told you that you have to be creative, actually select one or the other in terms of selecting either relative or absolute for the black points in one of the calibration screen. In this case, what I might do is go back and set the black point up so that instead of using relative, I might have actually used absolute. Again, this is something that is going to vary based on your needs and vary on the display itself, so it's something that you can definitely try. In this case, you know, if I change the value so that the average delta E is 2, which passes anyway. The maximum delta E is a little bit high for this display. So, you know, definitely if you play around with it, you can definitely change the settings around as well. So what I'm going to do here is I'll kind of wrap up the video at this point. Again, you know, you can try it out for the display. The calibration, it's one of those things. Photography, as I always say it, photography is the exact science of approximation, because I know like some photographers are extremely nervous about colors and so forth, and they want to be as accurate as possible, and what it comes down to is that you're going to get really close, but to be precise every single time, it's going to be extremely difficult. But if you, as long as you can get super close to what it's supposed to look like, then you'll be good. But anyway, this is the Palette Master Element software along with the SW271 calibration video. Thank you for watching.